Hello everyone, welcome back to my channel. My name is Lee. In today's video, I would like to show you how you can use Nix and ArgoCD to manage your Kubernetes cluster. The reason I want to make this video is that with the Kubernetes 1.34 release, we've got a new format called KYAML, which is a subset of YAML, and it looks incredibly similar to Nix. So I was thinking, instead of writing the KYAML, why not just use Nix, which is much more powerful and flexible. Without further ado, let me jump straight into the demo. I will open my terminal first. Okay, I'm going to temp folder and create a new folder called Nixidy. Next, I'm going to open my browser and go to my blog. So this is the blog post we are going to use. I wrote this blog post a few months ago to demonstrate how I use Nixidy to apply the rendered manifest patterns for managing my home cluster. In my experience, this pattern works really well. It gives me the extra clarity on exactly what resources are being applied to my cluster, especially for the applications managed by Helm charts. So let me just show you how you can start using Nixidy. Let me jump back to my terminal. And the first thing we need to do is just to create our flake.yaml file. You can copy this flake.yaml file from my blog post here. So this flake is pretty straightforward. Firstly, we've got the nixpkgs from the unstable channel. And it used flake utility to provide the each systems. And also we've got Nixidy here. On this flake, you define the Nixidy environments here. In this case, my environment is called dev, and the files for this dev environment is located at env/dev. This flake also gives you a dev shell, which means you can use nix develop to have the Nixidy installed for you. So let me just save this file, and then we can create a second one, which is called env dev default.nix. Of course, we will copy from my blog post. On this default.nix file, we define the Nixidy configurations for the dev environment. So here I've got the repository URL and the branch that I want to target, and also the root path for the generated YAML files. So in this case, it's manifest/dev, which means after we run the Nixidy switch command, the YAML files will be stored under this folder. All right, so let's save. We need to override. That's good. And then we can create our first application. So let me just copy this file first, and we will walk through what it does. env dev http bin.nix. Let's have a look what we have here. First of all, I've got an application name http bin, and I want all the resources to be created in the http bin namespace. And also I tell Nixidy, you need to create a namespace resource for me. And in terms of resources, firstly, I define a common label here, and this label will be applied on the deployment and the service here. Okay, so this is pretty straightforward. So let's save this file. We need to import this file back to our default.nix. So we can do imports. And because it's within the same folder, so we can just do http bin.nix. Once that's done, we can do nix develop -c shell. So this step, it will install Nixidy for me. So I've got Nixidy now, right? If I don't do that, I don't have Nixidy available, okay? Now we've got Nixidy, you can run Nixidy switch.dev, which will generate all the files for us. Let's have a look. Okay, so we can see here, under this folder, we have manifest dev environment for the applications. We've got application HTTP bin. And then in the HTTP bin folder, we've got namespace, service, and deployment, which is exactly what we defined here, right? Namespace, deployment, and service. So let's take a look at the application first. So dev applications HTTP bin. We can see here, this is the ArgoCD application, which is watching the manifest.def HTTP bin folder. So ArgoCD is responsible for watching all the file changes in this particular folder and then apply the changes to the cluster. All right. So let's have a look at the generated, maybe deployment. Deployment. So we can see this is the common labels that we have and the container image is there, right? So pretty straightforward. Moving on, we can see how we can use the Helm applications here. This is very common because a lot of applications that provide you the Helm chart for managing all the resources that you need. In this case, I will use the Kong Ingress Helm chart to demonstrate how you can use Nixidy for rendering all the YAML files this Helm chart generates. So we will copy this file and go to dev and then create this kong.nix, paste in. So we can see here, I want all the resources to be placed into the Kong namespace. Also, I want Nixidy to create this namespace file for me. In terms of Helm charts, it's for Kong Ingress chart and the version is 0.20.0 and this is the chart hash. And below is just the values.yaml files, normally you need to configure. So once that's done, we can save this file. And of course, again, we need to import this file back to our default.nix. So let's do kong.nix. All right, so let's just do a Nixidy switch again and see what other files being generated. Okay, that's done. So let's have a look. We can do this again. So we can see for the Kong folder, we've got so many YAMLs being generated. So these are all the resources that will be applied to your cluster for Kong itself. Here we can see we've got two deployments. One is for the gateway and the other one is for the controller. And then we can see all the CRDs here and then some cluster role binding and all the services that are being generated. So in this way, you have a clarity on, okay, when you apply these certain values to your charts and what are the resources being generated here. Okay, and you can also see there is application Kong, which again will watch the file changes within this folder by ArgoCD. All right, so let's move on to the next thing, which is the chart version. As you can see here, my chart version is 0.20 here. We can double check what's the latest version of the chart at the moment, which is 21. So we can change this one to 21. And because the version changed, the chart hash will need to be changed as well. So let's just remove it. Let's leave it as blank. And then we can do a Nixidy switch again. Nix will help us to fetch the chart and then give us the right values that we need to put in. So let's copy this file and then go back to Kong. That's all done. So you probably don't see much differences here, but imagine you are managing all your resources with a Git repository. Your CI will generate all these YAML files for you. So in the pull request, you can see exactly what changes along with the version change. Okay, so this is for the Helm chart version, how you can get the chart hash. Next, I want to show you a little bit about how you can manage your resources when the YAML resources are not defined by yourself, but by the chart. What that means is if you take a look at our con.nix, we didn't actually specify what resources to be included here, right? So it's all generated by this Helm chart. So what if you want to, let's say, patch a particular resource? In that case, we can use the application con resources here. So for example, I want to add an annotations to my con gateway proxy service. So what I need to do is just to copy here and paste it here. So we can see application con, which is exactly here, and then we put under resources, service con gateway proxy and metadata annotations, and this is just a metal LB annotations to give me a IP addresses for load balancer. And let's have a look our generated service file first. Okay, so con service. So you can see the service name is con gateway proxy. So currently I don't have the annotations for getting that metal LB annotation. If we run this again, and review this file, we can see the annotations is added, right? Before and after. So this is how you can patch individual resources that you want to add to the generated resources, okay? And next, I'm going to show you how you can use some of the Nixidy functions, I should say. Here, I will demonstrate how you can use transform and remove labels to remove some of the Helm labels here. So we will copy here, go back to our file, and same as previously, I'll just paste it here. We can see by default, we've got instance, managed by, versions, and the Helm chart. This is the chart version, I think. So we are removing the chart and removing the Kubernetes version here. If we want to remove, for example, managed by, we can also do that just by simply adding this. All right, so let's see what we get. Okay, so we can see now we have 3 labels removed, and it's not just for this particular service, it's actually for all the generated manifest. So let's go to deployment con and go to proxy. So we can see here, oh, this is a bit long, so let's have a look at the other one. Maybe try another service, maybe the controller one, I guess. So you can see the labels for the controller is also getting trimmed off. So this is really useful to use these transform functions to apply changes to all the generated manifests. Sometimes you need to pass in the extra options for the Helm chart to generate the right resources or adding the right permissions. In this example, we are using these flags to tell the home chart we have gateway API enabled on our cluster, so it will add the necessary permissions to the cluster row. So let's just copy this part and then go back to our terminal. We will add the con.nix and at the bottom, we will do Nixidy switch. Okay, so that's what I want to show you, how you can pass in the extra options for Helm chart. So moving on, let's see how we can manage the CRD installation as the application. So let's say you want to manage your custom resources definitions independently from the Helm chart. You can use this method. Essentially, you just fetch the CRDs as from the URL, and then you can pin the SHA-256 there. And then you will just use an ArgoCD application to manage the CRDs. So let's see how it works. Let's copy this one, go back to terminal, and create a file called kasgateway.api.nix. We will add this file back to our default.nix file. Let's save. All right. That's done. So let's have a look. We can see that we've got this KAS Gateway API CRDs in a separate folder, and these are all the Gateway API CRDs for 1.2.1 version. And we also have a ArgoCD applications to manage the CRDs in this particular folder. So in this way, when you upgrade the version of the CRD, you know exactly what has been changed. Maybe a new CRD being introduced in a new version. So you can see that in your pull request. So moving on, let's see what else we can do. So with the CRDs installed, we can create some CRD resources. So in this example, we need to create a gateway class and gateways. You can use the Nix language to define the service and deployment, just as we saw previously. But for the CRDs, we don't know that. So we can actually pass in just like a pure YAML files there. Nixidy will be able to just pull this YAML and then put it into a folder. Let me show you how. So we just copy this one and then go back to our con.nix. So we can see there is no gateway and there is no gateway class here at the moment. So let's go to the bottom, add it here, and we do another switch. So now when we see it, we can see the gateway class and the gateway is there. So essentially it takes this part and then put it inside your folder. So the application, the ArgoCD application will be able to manage everything for you. So moving forward, so let's say for some CRDs, you want to use the Nix language to define them, just like the service and route. So you can use different default values and common labels for all those CRDs. In that case, you can actually generate a modulus for that particular CRD. In this example, I'm generating the modulus for the Gateway API 1.2.1 and just for HTTP route only. Okay, so let's just copy this file and go back to our terminal, update the flake, and under this package, we just add an extra one. The extra one is called Gateway API, and we fetch from the Kubernetes Git repository, and then the version 1.2.1, and then we are generating this module for HTTP route only. All right, so let's just generate this thing. We can do Nix build. Once that's done, we will create a modules folders under env.dev, and then copy the result, which is the module we just generated, under here. All right, so let's have a look. We can see that we have, manifest. So we have env modulus KAS Gateway API Nix. Perfect. So next thing, we just need to include our modulus as the application imports here on our default.nix file. And we are ready to write our first HTTP route in Nix language. Let's do it. So let's just copy this one back to our HTTP bin.nix. We will add this under the resources here. So this is the resource, and we will just add this under the service. Of course, we need to delete these 3 dots. Save. So now we can generate our HTTP route object. Let's try that. Okay, so let's have a look. If we take a look at the HTTP bin, we can see the HTTP route has been generated, right? So if we take a look at manifest dev HTTP route, this is exactly how we define using the Nix language. Okay, so now we know how we can write the Kubernetes native object in Nix, how we can import modulus, how we can use Helm chart, and we know as the structures that we have applications to manage individual folders. What's next? So the next one is just to generate a app of the app. Basically, we will create a Bootstrap app to manage all the application inside the apps folder. All right, so we just apply the master app to the cluster. The ArgoCD will be able to create all these applications, and then it will manage all the resources for individual folders. All right, so let's see how we can do it. So the first thing we can do is just to run the Nixidy bootstrap.dev. So let's see, bootstrap.dev. It will generate these applications for us. In the newer versions, I think it introduced a new parameters that you can generate that automatically for you. So you don't need to do this manually, but you can feel free to do this manually and then store in a folder and then apply it to your Kubernetes cluster when ArgoCD is installed. Okay, so that's all I want to share with you today. On this blog post, I also talk about the ArgoCD management and how I use swap secrets, SSLs, etc., etc. Basically, I've covered how you can use Nixidy to generate different resources. The last thing I want to show you is how I actually use that with my modulars, so you get the idea on why I think Nix is a better language for managing all these resources. So I will go to my cluster and let me show you one thing. So for example, I've got my HTTP bin service here, and I've got a specification, OpenAPI spec here. So essentially I can define a function to take a OpenAPI specification as the input and then generate all the HTTP routes for me. So to give you a context, if I open my HTTP bin folders here, you can see I've got 5 routes being generated, which is just here. If I remove this and I do Nixidy switch dot, which is called APIs. All right, so you can see how many more routes are being generated automatically for me. With Nix, you have that kind of flexibility to define your own function or modulars to manage all your resources. I think that is something KYAML definitely can't give you. All right, so that's all I want to share with you today. I hope you start using Nix, of course, as always. And if you have any questions, please leave your comments down below, and I will try my best to get back to you. And thank you for watching, and see you in the next one. Goodbye.